What are we going to be talking about today? Is analyzing vulnerabilities through business risk. And our presenter is Mrigakshi Goel. She's an information security engineer at Finning, and she's passionate about speaking for cybersecurity and following best practices to create a cyber safe world. She's currently working, as I mentioned before, at Finning and has worked in application security in Optiv, Buckcrowd, and Accenture in the past. With 9 years of experience in the IT industry and a master's in cybersecurity, she's here to discuss a few common vulnerabilities and how to mitigate the associated business risk. She believes that while the OS top 10 is focused on shifting left, understanding the attack surface and the attacker's way of thinking is also crucial. And with that, we'll leave you with Mrigakshi. You can take over, Mrigakshi. Thank you.
So we will cover a few 4 random vulnerabilities from the list of top 25 common web weaknesses list. They are the most dangerous 25 web weaknesses. We will cover SQL injection, a short demo of the injection, things about how it can affect your business, and a few mitigations. Then we will discuss file upload bypass, cross-site scripting, and server-side request forgery with short demos and more about them. So let's start with understanding what we are presenting here today. Well, attack surface is basically entire public-facing area. So attack surface could include public websites, a company public websites, stolen passwords, your SSL certificates, VPN, employee portal, basically everything that public can access. When we talk about web applications, they are basically the home to your business on the internet. Our goal here is to secure the code and get a more robust code. Well, let's differentiate a little bit between security testing and web application security functionality testing and web application security testing. So when we talk about functionality testing, it's basically more focused on intended functionality, which is the functionality of a software that we are developing. But there are some different functionalities that come in hand with after the software is developed. That is the actual functionality, and that can have issues. Identifying the source and the sink is very important at this point. When we talk of source, it means the inputs where an attacker or a user can put values, certain values, and those values could include an attack. Those values are generally meant to be normal inputs like credit card numbers, your name, email addresses, anything. But they could also include certain values of code that could result in an attack. Well, our focus here is that. So web weaknesses are basically those web weaknesses that the weaknesses that are included in these softwares and are also called vulnerabilities. So let's start with SQL injection. It is a very common high priority issue that a lot of people are facing today, a lot of businesses are facing today, and a lot of attacks in the past have been due to this injection. It is basically a code injection technique and is present in data-driven applications. By SQL injection, we mean that applications that use SQL queries can be altered in SQL query logic and can lead to bypass of security checks and can also modify the backend database. Sometimes it can also execute system commands. Let's start with a quick demo so I've also mentioned the CWE number so that you can maybe later on go and search about what this attack is. You must have heard of SQL query like select star from table name, where username is administrator and password equal to something XYZ123. Here we are going to just edit this query to something like select star from table name, where administrator, and dash dash. After dash dash, everything gets commented. So this is a website that I'm using here. This is a attack website lab. Um, so there's a login panel on this website, and I'm going to put administrator and something in the password field. Then I'm going to intercept this request. Let's see what happens. So I intercepted this request and it says username equal to administrator and password equal to pass. Let's forward this request. Let's see if I get to log in. And if not, we will try the other method where I'm going to comment out everything after the administrator. So I just turned off and it says invalid password and username. Now I have put administrator, inverted comma, and then dash dash. So let's see the query again. It says administrator, inverted comma, and dash dash, and everything after that will be commented out. Let's see if we can bypass this. So successful. We have basically entered a web application without even knowing the password. This is the impact of SQL injection. This is a new attack that I'm showing. So if you see GIFs, I'm trying to search category GIFs in a website. When I search category GIFs, it shows me GIFs. So behind query should be something like select star from products where category is GIFs and release equal to 1. But we want to alter it to where category equal to GIFs and everything after that is true, which means a true statement like 1 equal to 1, A equal to A, any statement that gives everything true except for GIFs equal to gift. So this will give me more items, not just gift items. So I'm going to change this query, GIFs and then inverted comma or 1 equal to 1. Let's see what happens. And dash dash means everything after that should be commented out. Let's see what happens now. I have intercepted this request and then forwarded this request, and I'm able to see everything just not released. So everything except gifts, and because I just said that or true, a true statement, which is true forever. So this was a short attack. Let's see what is the business impact here. Well, we can see that confidentiality is definitely affected. It is a huge area where an attacker can see and read sensitive data. Access control is impacted. It is possible to connect to a system of another user without even knowing any password. A lot of times access control is affected. Then if there are some data or there are some passwords stored in a database table like SQL database, then we can also edit the passwords of other people or edit the salaries, edit certain fields through SQL injection. So integrity is also affected. Integrity is basically changing the data which is present in the table. So someone does not need access to the database to just modify the things in the table. Let's start a little bit about another vulnerability, which is cross-site scripting. We will discuss the how we can lower the impacts of all these in the end of the presentation. So we move on to cross-site scripting. It is also an injection attack. It is basically a malicious client-side script that can be injected by an attacker into the web server. These attacks are very, very common and very hard to prevent if there's no, it is not taken care early in the life cycle. It is also a common occurrence in OWASP top 10. It is sometimes low priority also, but generally it is high priority. Sometimes we can do self attacks in cross-site scripting, which can be low priority, but in most cases, cross-site scripting can affect a lot of things in a website. Let's start with a quick demo. Again, I've mentioned the CWE number 79, so you can maybe later on go and search about this attack. Uh, there's the similar website that I've taken. It's from Portswigger. I'm showing, so if I write script alert 1 script, it just shows me an error like this. Uh, this is like a cross-site scripting attack where I can insert anything into the search portal and it shows an alert box. And then I'm going to show you a post. This is a post and it has an option to leave a comment. Now I'm going to put something like script alert 1 script. And then I'm going to fill the fields with anything. Just filling the fields with anything. And then I'm going to post the comment. So this script alert 1 script is stored in this blog. And whenever I'll go to this post, I'll see this message. This is different from the first attack because in this one, the message is stored on the database. And whenever I'll go to this post, I'll always get this message. I'll just try to go to home again and go to this blog again. I'll just go to this blog and then I simply receive this message. This message could have been anything from an attacker. And unless I click OK, this won't get to the back to the website. Let's see what has been impacted here. Do you think access control is impacted? Do you think confidentiality is impacted? Well, yes. Someone can get user cookies in a cross-site scripting attack. So user cookies are basically some of the attributes of a user that a user is storing on a website when logged into their application. There are other user cookies that are not related to login, but in this case, application user cookies can be stolen by a cross-site scripting attack. A malicious script can be inserted that can have access to the user cookies. Sometimes integrity, confidentiality, and availability, everything can be affected. If you can execute an unauthorized code or commands and run arbitrary code on a victim's computer, cross-site scripting has huge issues with access, confidentiality, integrity, access control, and availability. They can also lead to complete compromise of your systems. Let's see a little bit more of impacts of cross-site scripting. Unstructured data can enter your web applications, complete compromise of accounts, and manipulation of stolen cookies. To prevent this, we sometimes allot cookies to normal people who reach a website so that when they make a request, we can compare those cookies with the normal cookies that was entered by a person on the website so that no illegitimate requests are sent by an attacker. Compromising of confidential information is also possible. And there are other damaging effects like disclosure of end user files, installation of Trojan programs, redirecting the user to a new page, and modifying the presentation of content. There's a new attack coming up now, which is file upload bypass. In this attack, this is a little bit less priority than the first two described here, but it can definitely be escalated to a higher priority issue if it leads to remote code execution. Some of the file upload bypass can lead to getting the entire shell of the web server and get the commands executed. So this software is allowed to upload and transfer files of dangerous types. This can lead to modify the files on the web servers. Let's start with a quick demo. Again, I have mentioned CWE number 434, so you can go and later search about this more. So this is a Portugal website. This is my lab where I want to access a certain file path. I'm going to upload a file, and I'm going to show you the contents of the file in a little while. So this is Avatar, where I'm asked to choose a file to upload as an image. But instead of an image, I find a PHP shell and I upload it. Let's see the contents of this PHP shell by intercepting the request on Burp Suite on the other side. So I have intercepted the request on the left side, PHP echo file get contents, and I want to see home Carlos secret. I want to see the items on this file path. So I want to see the items on this file path, but this server does not accept a PHP file. txt/php is the content type. If you can notice the content type, form data, content type, content disposition, these are all mentioned while uploading a file to the server. Let's forward this request and see if this gets uploaded. Sorry, the file has not been uploaded. So this file did not get uploaded. Let's try doing something attacker-like. Choose file, and then again, we try to upload this same web shell.php. As you can see, we have again intercepted this request. PHP echo file get contents home Carlos secret. This time, I'm going to edit the content type from text/PHP to image/JPEG. JPEG is the content type that is accepted by this web server. Now I forward the request and I see that PHP file has been uploaded. Now let's see what this PHP file can do to the server. I'll go to the avatar and go to the source code, inspect element, and go to the page source. And I'll see what this avatar source looks like. Let's find the avatar source here, files avatar php.webshell. And I get the content of home Carlos in here. So I could get some content of the web server. Just to analyze the business risk here, we have identified that we were able to get integrity, confidentiality, availability, all of them compromised in this case. Execution of unauthorized codes and commands. And arbitrary code execution is possible by uploading the file, which is interpreted and executed by the web server. Okay, let's talk about a new attack. This is called server-side request forgery. Server-side request forgery is basically used to get connected with something internal on the web server. We can request some internal-only services. We can force the server to connect to arbitrary external system, and we can leak some sensitive data such as authorization credentials if they are stored on the web server or they're used in plain text. So it is not a very high priority, but I wanted to discuss one okay priority as well. So these are some of the random attacks that we have taken from the common the web weaknesses, 25 most dangerous web weaknesses, and let's start with it. So I'll again go with the demo of CWE 918. You can look it up on the web. So this is a lab for server-side request forgery. Uh, we have a local host admin that we want to get into. So let's see what we can do here. There's an option to check stocks, which says 860 units. This is a normal website that checks stocks. There's a button on this website. Let's see what happened. What's happening on the back end here. Uh, so we can see that it is requesting something in a URL encoded manner. Let's decode this URL and see what happens. When we decode the URL, we see that it's saying check question mark product ID 1, store ID 1. Now, let's send this request to a repeater. Repeater is something that's just going to repeat the same request by editing it. So we are going to edit this request here and see where we can reach on the internal web server. Let's see if we can go to http:// localhost. Let's send this request and see what the response comes. It should not have been 200 OK. 200 OK means that I'm able to reach somewhere in the local host. Now I did admin localhost/admin, and then again, this is the another view of the same request that has been processed. I see that users Carlos and two of the users are listed. I want to delete these users, and this is an admin portal that I normally don't have access to, but localhost/admin is given me access by manipulating this request. I see that admin/delete question mark username equal to Carlos is a delete, is the way it deletes a user. So I'm going to just edit my request to admin/delete question mark username equal to Carlos and forward this request. Although it says 302 not found, 302 found, this means it's going to redirect somewhere, but there's a possibility that user may have been deleted or not deleted. Let's see what's happening here when we go to localhost admin again. So we get OK and we go to render. And now notice that only one user is left, winner. The other user has been deleted. So we have successfully deleted a user by using server-side request forgery. Well, what we see here is that confidentiality is impacted by reading application data and also modifying the application data. Execution of unauthorized codes and commands can lead us to get into the internal files. And although usually SSRF is not very high impacted, but the one that I have shown here has a high impact on deleting users. Obviously, deleting a user is a huge issue if some of your users get deleted because of this vulnerability. Let's start with mitigations. Before we start with mitigations, I'd request all of you to maybe talk a little bit, ask some questions if you didn't understand something in the presentations I did so far and the demos. Um, does any of you have any questions?
There are some questions that were dropped in the chat window.
Okay.
One is from Michael. It says, for any that are less familiar with cross-site scripting, you are saying you can execute commands on an unsecured website from an entirely different website or web source.
So the first question is, can unsecured vendor sites or organizations does business lead to more successful supply chain attack if compromised through SQL injection and cross-site scripting? Yes, if the vendors have this issue and we are connected with the vendor, there's a third party that has cross-site scripting issues. and you're connected with that vendor, then definitely they can cause issues through SQL injection and cross-site scripting.
Then
Next.
there's another. Yeah, the next question says, what are some of the best resources you found at educating yourself on the ever-evolving landscape of threat vectors and vulnerability management?
The best way I educate myself is through Maitre website, MITRE. They have a list of CVEs and CWEs that they keep on discussing, and they come up with how those attacks are done. So educating the developers and educating like, your entire security team is very, very important. We have web security standards coming up. Everyone is excited about shifting left and getting more into the secure DevOps and adding security to early on in the development phase of application development. So I have listed some of the references, and I'll definitely exaggerate on them when I reach there. So let's start with mitigations then. So one of the biggest mitigation is input validation. It is very important for all of these attacks that I discussed today. If you talk about SQL injection, then having an allow list of input validation, where if you have a not allow list, like block list, where you reject certain symbols, where you reject certain things, it does not solve the issue, because there will always be certain things that will be that an attacker will be able to find. So allow list is very, very important in input validation. You can go to OWASP Enterprise Security API, ASAPI library. It has a lot of recommendations for input validation and encoding and output encoding. So escaping all user supplied input is a good idea in SQL injection or XSS or file upload bypass. All of these attacks are a little bit mitigated with input validation. Having a perfect injection resistance in a cross-site scripting attack can mitigate the impact of XSS to very low. So all variables should be validated and escaped or sanitized, which is called perfect injection resistance. So if there is an attack, if there's an XSS attack, and we have a firewall to prevent that XSS attack, but the application is not preventing the attack, then it's just a matter of time that someone will find out how to bypass the firewall and then get into your application. Therefore, having a defense strategy which has depth, having resistance for XSS in the application as well as in the firewall are both important. So accept known good in input validation strategy, which is called allow list, is also important for XSS. Again, then file upload bypass also has this thing. For example, we are uploading a PHP file. Now, this user, this application creator did not accept PHP, but it may accept PHP 5. And then that is not a good idea, because attackers can find different extensions like php.jpg can also be accepted. Sometimes there are other filters that can be bypassed through different methods. Therefore, accepting known good is a better idea, like just accepting JPEG is a better idea than having the block list. So do not rely on looking for any malicious inputs. Always accept the good. And in SSRF, you may want to validate the URL or the IP address that it resolves to only external IP addresses, not your internal assets. So input validation is also there in SSRF, but it is of a different kind. There are some other mitigations that we can talk about. Automated and manual analysis of code at different stages. So static analysis of code is very important, analyzing the code early on in the development phase, finding issues with the code and identifying the source where the input is put by an attacker or a user, and the sink where the input reaches, where it can make an effect in the application. Always run your code in lowest privileges required. So if you can run your code in a high privilege, you can also run your code in the lower privilege, and give only lowest privileges to every user possible in your application. Always educate your developers, and educating developers is very, very important about manual and dynamic testing, because if we keep focusing on the traditional way of testing, then we will not be able to eliminate the bugs coming in the future. There are many different vulnerabilities getting new vulnerabilities getting in the market every year. So we need to educate developers and have a discussion of security as an important topic. Enforce separation between data and code. So some of the applications can be secured if we have a good separation between data and code. Uh, Data and code, by data and code, we mean that data could be something that is an input value for a field, but code is something that can interact with the code of your application. So if developers can identify that some input coming is a data and other input coming is a code, that can be helpful. Output encoding is also one of the important ways for SQL injection and XSS. Uh, we do have to read a little bit more about this, but considering the time, I have not discussed this much. So firewall as a defense in depth strategy is very important. Uh, Firewalls have some strategies for XSS and SQL input validation and other input validations. So we can learn from the firewalls what they are taking care of, and also implement the same in our applications as a defense in depth strategy. Identifying especially dangerous operations. So some of the operations can be especially dangerous. For example, we can identify that a user is logging in from a different location than usual. That is a dangerous operation, and a different alert should be sent for this dangerous action. So you might have noticed that there are some alerts on your phones when you log in from a different device, or there's something new that you do. Uh, Identifying a dangerous operation is in that category, and it's very important to identify something as a dangerous operation. Use double submitted cookie. So let's talk about this a little more in elaborate way. So double submitted cookie means there's a get action and there's a post action. Get action is generally sent to get some data from the web server. Get action can have a cookie that the user is using. So when a user visits a website, they should be allotted uh, a form number, a different form number. And when a user does some action on the web server, for example, a post method, then they should be using the same cookie while they are using the get cookie. Attackers normally just use the post actions, not the get actions. So we can compare the get actions and post actions and see that the cookie remains same at the end. Most importantly, keep moving left. Don't rely on the pen testing in the end. and have application security in the first phase, early development cycle. So these are the references that I was talking about. CWE, most common web weaknesses, by matri.org, and from Portugal. These are my favorite places where I learn about them. There are definitely many different blogs, many different write-ups that people use, but these are my favorite. So
Thank you. Thank you, Mrigakshi. So this will open more for questions for the rest of the attendees. We really appreciate your time and everything that you explained. There's one on the chat, and then I have a couple of. So let's start with the chat one. In your opinion, if companies offer bug bounties, does that increase their digital liability, or does it help with with an organization's overall vulnerability management?
So I do think that bug bounties can help organization in a certain way because it's crowdsourcing and a lot of researchers can give certain bugs, but also it exposes the application to a lot more people than it should. So if bug bounties are given to a certain audience only, security wise, it is better because we are seeing so many different attacks like Uber attack few days ago, and we cannot identify who is an attacker and who is a security, who's a good person for our company. So it is very hard to, when we are doing bug bounties, it is very hard to identify the correct audience. Although I do think that it is a great idea as a person who's doing bug bounty, you don't have to have a contract with them and they can still find some of the weaknesses that nobody ever found in your company.
Thank you for that. So you kind of explain and walk us through the different vulnerabilities and how to mitigate them. But could you kind of provide us some examples of what you have seen out there in terms of real attacks and the impacts of them? You just mentioned about Uber, so maybe you can elaborate a little bit of that, or other ones that you may have been either exposed or just seen as part of your experience.
Yeah, all these attacks are real attacks and they have happened in the past. Cross-site scripting, if you can see, the first cross-site scripting attack was about around 2005, so many years ago, and it's still valid and available in so many different companies. ServiceNow just patched their vulnerability for a cross-site scripting attack in 2022. So you can see that so many years later, we still have cross-site scripting there. We still have SQL injection also there. If we talk about Uber, the Uber attack was that continuously this person was getting alert, and then social engineering on the other side. The IT reached out and said you have to accept this because, and the employee was also getting the alert again and again, so they accepted, and the attackers managed to reach everywhere in the organization. So yeah, this is a good example, but we have seen cross-site scripting attack in British Airways, in everywhere. Lots of big companies have cross-site scripting attack in the past.
When you were talking about testing the code, like what type of tools you have seen being used? Is there anything that you kind of have as a preference? It's not that we want to advertise one or the other, but just out of curiosity, based on your experience, what have you seen?
Yeah, static analysis can be done through so many different tools that are available in the market. Snyk, I was reading about Snyk the other day. Snyk is a very nice tool. There's Veracode. There are so many on the same lines of these platforms that update their database every day about 3 or 4 times. and they have the updated list of vulnerabilities. And according to the vulnerabilities that came up in the market, they check your code, compare your code with those vulnerabilities and find out if your code has those vulnerabilities. Basically, this is done by identifying the source and the sink. And a similar way as I explained, that the source and the sink can be analyzed to have some issues with your code, and then we can include in more safe practices and more secure coding practices.
Thanks. And I saw when you were explaining every single one of them, at the bottom you say sometimes that was a low priority one type of vulnerability. So what do you mean by that? As in, like, if you had a set of vulnerabilities, that's the one that, can go to the bottom of the rest? Or what was that related to?
Yeah, so in a server-side request forgery, I said that it is a little bit low priority because in most cases I have seen server-side request forgery has been that it can get some of the messaging in the organization, or it can get some of the requests in the organization, but it did not reach to delete something in the organization or modify something in the organization. But in the case that I showed, that was definitely a high priority. So it's generally a low priority, but there could be some escalations that can reach high priority in certain cases.
So I'm opening oh, there you go. There's one question here. With your SQL injection attack example, you mentioned that there is an SQL injection attack. I am just curious, is that different from the SQL injection attacks we used to know, or can you explain what you mean by saying a new SQL attack?
A new SQL attack?
Yes.
I'm not sure what you mean by a new SQL attack, but I just showed two examples of SQL attack. So one example was where I was trying to bypass the login by without sending the password. So I put in a query select star from the database, and then where login username equal to something, and ignore dash dash ignore everything after the statement. So what happened was that the password gets ignored. So whatever the password was, it was ignored, and I was able to log in as a user only by knowing the username. In the other case that I showed for SQL, there was a where query. Uh, it's nothing very new. It has been existing in the past, but there can be different ways of SQL injections that can come up because we are doing a block list, not the allow list. How much technical enterprise do individuals need to have to execute these types of attack? So they don't need to have any enterprise. We have seen in the past that there are very young attackers also doing the attacks. So I don't think they need any enterprise, but there are some that have enterprise. For example, can script kiddies perform these types of attacks? I guess, yeah. Script kiddies can perform these kind of attacks depending on what their intentions are. Script kiddies are generally is generally said for those who don't have intention of doing something bad. Yeah, correct. By Spider, that Uber was had by 18-year-old, as far as we know.
Perfect. Well, thank you. I guess going back to Samuel's question, he was just saying, like, based on what you were explaining, you keep on saying this is a new SQL injection attack. I see, like, out of the ones that we know and exist in terms of types, was there a new one, or we were just saying a new in terms of you showing what you were doing on the screen?
So I actually don't remember when I said new, but New as in that there could be some attacks that we have not identified before. Like for example, if you talk of there's an SQL attack that is used in errors. If someone gets an error in your website, then they can manipulate after the error, and or there is a wait for attack. Wait for attack and error attacks are the newer ones, but definitely you can use SQL map, and there are some platforms that you can use to identify SQL injections. So in the wait for attack, the attacker is trying to make the server wait for few seconds or few minutes. And if the server gets to wait for few minutes, then another query can be added after the attack. So those are more sophisticated and newer in that way.
What is your thought on risk-based vulnerability management?
Yeah, I agree that risk-based vulnerability management is a good idea, because so if there's a high priority attack, for example, SQL injection and excesses that I discussed before, and if there's an attack that can be escalated to a much higher priority, then that can do more harm than thousands of low priority bugs. Although the low priority bugs can be put together to make a certain high priority bug. So always focusing vulnerability management on risk is the best idea, because if we do not set our priorities, then then the time will go and we will still have those issues in our companies.
Thanks. Can SQL injection attacks still lead to buffer overflows?
Yeah, I think they can, but I don't have a discrete example right now available. SQL injection with buffer overflow.
Perfect, thanks. So unless there are any additional questions, we want to thank Mrigakshi for her time and the knowledge that she shared with us. Thank you again for being present here today.